So lesson number 3 looks at multiplying two binomials. We look at a couple of different methods. We look at using our algebra tiles, using some area diagrams, and then using our symbols or straight algebra. So if we look at the first one, what we have is x plus 3 times x plus 2. So again, we use this idea of length times width. So if I go length times width, I get my square. Length times width, I get a rod here and a rod here. If I take my rod and I turn it, I can put one here. Take another rod and turn it. Take another rod and turn it. And then these ones and ones will leave me with ones all the way through. So if I record what I have drawn out here, I have 1x squared, I have 5 x's, and 6 ones. So if I look at B, along the top I have x plus 4, and along the side I have 2 x's plus 1. So a rod and a rod gives me a square. That will be shaded. Another rod and a rod is another square. A rod and 1 leaves me with a rod. I'm going to get rods all through here. It's important when we're drawing these that we try to make our rods much skinnier than our squares. Then again, I have 4 more rods, and afterwards I'll have to go through and shade all 8 of these because it's a positive and a positive. I have a 1 and a rod, so it's going to give me another rod down here. And then I've got these ones and ones. And again, everything is shaded. So I have 2 of these x squareds. I have 4, 8, 9 of these rods, and 4 of these ones. So again, similar process as before. I want you to attempt to do C and D on your own. And if you get stuck, or once you're done, you can press play and look through them. So with C, I have an x minus 3, because these are 3 negatives. Then I have an x and 2 negatives. So x minus 2. My x and my x is going to give me an x squared, and then my negative 1 with my rods are going to give me these negative rods, so I don't have to shade those in. And I'm going to get negative rods right here as well. And then my negative 1 and my negative 1 will give me a positive 1. I have an x squared. I have negative 5 x's this time, and positive 6 ones. And finally, in the last one, I have 2 x's and a negative 1, and an x and 2 positives. So an x and an x gives me a square. X and an x gives me a square. An x and a negative 1 will give me a negative rod here. then I get a positive rod going across here, and I will get 4 of them. And then I'm going to get 2 negative 1s because I've got a positive and a negative. So this time I have a 2x squared. I have 4 positives and a negative, so I get a 0 pair here, which leaves me with 3 positives. And then a negative 2 ones right here. So again, like in the last section, algebra tiles are great for visualization. However, they take a long time to draw out. So we want to try to shorten our method. We want to try to find some patterns or some other ways that we can do this. So we can look at the idea of an algebra tile diagram or an area model. So with this one, my x plus 3, x, positive 3, x, positive 2. So that becomes our outside grid. And then it's x times x is x squared, x times 3 is 3x, 2 times x is 2x, 3 times 2 is 6. The x squared stays by itself, the 6 stays by itself, but these two are like terms, so I can add them to get a 5x. So I'm going to look at class example number 2. Again, the idea being I can do the first one with you, and then you can pause, and then try to work through some of the others. So I have a 5x and a negative 6, and then I have a 2x and a positive 1. There's my grid. 5x and 2x, 10x squared. 2x and negative 6, negative 12x. 1 and 5x, and 1 and negative 6. And there's my square completed. Now I collect the like terms, or I put it all together. So I have a 10x squared. These are my like terms right here. So I get a negative 12 and a positive 5. And I'll get a negative 7x and a negative 6. So again, the idea being that you can pause and try to do the next 3 and then play through each of them. So with B, I have an a squared and a negative 5. And horizontally, I have an a squared and a negative 8. So my exponent rules tell me I add the exponents. So an a squared times an a squared would be a to the power of 4. Negative 5a squared, negative 8a squared, and a positive 40 when I do my multiplications. So my answer, I get a to the power of 4. These two are my like terms, negative 8 and negative 5 gives me negative 13 a squareds and a positive 40. For C, I have a 3p and a 2q and a p and 9q. So p times 3p gives me 3p squareds. P times 2q will give me a 2pq. It's always easiest to put my letters in alphabetical order because then it's consistent each time. So a 9q and a 3p gives me a 27pq. 9q and 2q, 18q squared. Because remember, I'm multiplying each time. That's my operation. So now I write this out. I've got my 3p squared. Here are my my like terms, I have 2 PQs and 27 PQs. That gives me 29 PQs. And then my 18 Q squared. So then the last one, I have an A, a positive B, a C, and a positive D. C times A, put it as AC, B times C, BC, then I have AD and BD. So this time there are no like terms, so I have an AC plus AD plus BC plus BD. So this idea of area models can actually help with multiplication. If I take something like 32 by 34, if I had to do this the pen and pencil way, pencil and paper, there's a lot of different ways I can multiply it out, but one way with column methods is I think of this as, so 4 times 32 is 128. And this should actually be thought of as 30 times 32, which would be 960. And I get 1,088. The other way that I can look at it is I can split it up. 32 I can write as 30 plus 2. 30 plus 4. 30 times 30 is 900. 2 30s is 60. 4 30s is 120. And 4 2s is 8. Add this together, I get 900, 1,020, 1,080, and 1,088. The idea being you're not using a calculator. So if I look at class example number 6, use an area diagram and no calculator to determine the following. I can split 43 as being a 40 and 3. 51 becomes 50 and 1. So if I take 40 and 50 and multiply them together, 2,000. 3 50s is 150, 140, and 13. So this gives me 2,193. So try to do the same thing with B. So in B, I have 70 plus 6 and 80 plus 2. So 80 and 70 will give me 5,600. 6 80s becomes 480. 2 70s is 140 and 12. So I have 5,600 will give me 6,000, 61, 62, 20, 62, 32. So what I want you to work on is questions 1, A, C, and E. 2, B, C, and D, and 3, B, and D. So yesterday we finished off class with multiplying a monomial with a binomial, or sorry, multiplying 2 binomials using algebra tiles. So we actually drew out the arrays of the algebra tiles. How much fun was that? Time consuming. We don't want to have to do that for large numbers, for multiple drawings. We did area models. How'd the area models go? Not bad? They're nice. They're compact. It organizes our work. So there's a third method. The third method uses the distributive property, which we've already talked about. We've already looked at the concept of the distributive property, which says take what's in one term and distribute it to everything in the other term. When we looked at the distributive property in the last lesson, we were looking at a monomial being multiplied by a polynomial. This time we have two binomials. We still use the same concept of the distributive property. We distribute the x to both terms inside the second expression. So x times x is x times 2. 3 times x.
3x.
And 3 times 2. Collect the middle terms, which are the like terms, and how many x's do I have?
5.
Anybody see the little face that I drew? Here's his chin, his little smile, and then kind of his eyebrows or something or other.
Because he dies. Lives blind.
No, either you see the face or you don't see the face.
You don't see the face, you fail the class. I'll say that.
You don't see the face if
You fail the class.
you fail, yeah, fail the class.
You don't get
Everybody sees the face now.
Yeah. It's cool.
My math teacher called this George. So it would be like, how do I do this question, Mrs. Insmar? She'd be like, you George it. Oh, okay.
I totally understand.
So we use the distributive property. We take A and we distribute it to the two terms in the next expression. A times 2A.
A times 2a.
2a squared.
Thank you. A times negative 1.
Negative 1.
Do I need the 1 in front of the A?
No.
No, but I do need the negative. Negative 7 times 2A.
Negative 14. No.
And negative 7 times negative 1.
Positive 7.
Collect the like terms, and how many A's do I have?
Negative.
Negative 15. Okay, I'm going to give you some time. I want you to do the next 3 questions the same way, using the distributive property. Okay, let's finish the rest of these products out. For C, I get a p squared, a negative 8p, negative 8p, a positive 64.
That's a P and a Q.
Oh, yes, it is. Sorry.
I just wanted to see if I had more times.
So then when I distribute this one, I get a PQ minus 8P minus 8Q plus 64. Can I collect any like terms for this one? No. So it would stay exactly as it is. When I get to D, x and x gives me an x squared. When I multiply x with a negative 5y, what would I get? Negative 5xy. So we put our letters in alphabetical order, and our coefficient always goes out in front. So if I take 4y and I multiply it by x, what would I have? 4xy. And then 4y times a negative 5y. Come on, guys. Negative 20 y squared. So 2 y's, right? So now when I collect the like terms, how many xy's do I have? And is it positive or negative? So if I follow this distributive property, the one thing that you noticed, your like terms tend to end up in the middle most of the time. Not all of the time, but most of the time they're going to wind up in the middle. And the last one, 9a squared times 5a cubed would be what? Okay. 9a squared times 6. Negative 1 times 5a cubed. And negative 1 times 6. Are there any like terms to collect? No. The only thing that I could do is I could decide to write this in descending order in my powers of a, in which case the 5a cubed or negative 5a cubed would come first, and then the 54a squared. So I would just reverse these two terms. Now, if you talk to classes above you about the distributive property and multiplying this out, they will use the word FOIL. Oh, you FOILed it. FOILed it stands for, this is the first term times the first term. So x times x was the first term times the first term. In addition to being the first term, I can look at these two as being the outside terms. O for outside. Then I would stand for inside. And if this is the first term, this would be the last. So then I get the last times the last. So I can think of the acronym FOIL to help me use the distributive property, although FOIL doesn't work if I have anything more than two terms. So if I have to take a binomial and multiply it by a trinomial, FOIL's not going to work for me. FOIL works when I'm multiplying two binomials. So, do class example number 5. FOIL means use the distributive property. That's what FOIL means. So if I FOIL these out or use the distributive property, what do I get for 5a?
X squared plus 4x. 6x plus 24.
And how many x's do I have?
10.
Okay, what about for b?
Y squared plus 2y minus 7 minus 14
How many y's do I have?
negative 5
Okay, what about c?
3x squared minus 15x plus x minus 5
So I get 3x squared
minus 14x.
Okay. D is a bit tricky. If your answer for D is 36a squared plus 25b squared, you're wrong. Why are you wrong?
Exponents outside the bracket.
6a minus 5b squared means take that expression and multiply it by itself twice. So if I multiply it by itself twice, 6a times 6a, there's my 36a squared. But then when I do the 6a times the negative 5b, I get a negative 30ab. When I take negative 5b and multiply it by 6a, I get another negative 30ab. And then the negative 5b and the negative 5b. So it's not that it was completely wrong, it's that we miss the middle terms. So my final solution is 36a squared minus 60ab plus 25b squared. That, by the way, is the most common mistake made for that type of a question, which is why my recommendation to you is when you see a question that's written like that with the squared, scribble out the squared and rewrite the second expression a second time so that you're less likely to make that mistake. So I would like you to work on questions 6 to 9 to finish this section.